Hi, everyone. This is Roger from the engineering team, and I'm going to talk about reference states and JPA. So I'll begin with reference states. So from being involved with customers building apps on Corda for a while, there's been a need for Corda to support reference data. And pretty much all use cases require some kind of reference data. So it's some kind of data or state which is issued by a party on the network, which is then used by others to make some kind of business decision. So an example might be something like FX rates or reference data for financial instruments, token definitions in the token SDK. There's like a whole range of stuff that you might want to class as reference data. Usually, it needs to be the case that everyone operates on the same version or the most current version of that reference data. And it just so happens that Corda is quite useful for that because we've got the ordering service, the notary that can help us do that. So when I was building a bunch of stuff for the cash issuer project last year, I needed a state that kept track of issuances on a network, and this state needed to be used by a bunch of nodes, but it could only be updated by one particular node. So the problem I had was that if another node wanted to use this state in a transaction, they had to consume that state. So they had to keep consuming it every time they wanted to use it. And this doesn't really make much sense. The effect is that you get lots of contention over that state because you have the maintainer of it that wants to update it at some point, and then every time somebody else wants to use it, then they also have to consume it. But then you also have to distribute the consumed version of it, even though nothing has changed, the consumed version of it to everybody else, such that they can then use that transaction, that state in a new transaction. This is really just I guess a number of options that you can use for implementing reference data. So as I said, you could use standard contract states, but you have this contention problem. You also end up with very long chains of provenance because you keep consuming this state when you use it. The chain of provenance obviously gets one longer every time that you use it in a state. When I say use it, you're not really changing any information or data within the state. It's literally just included within a transaction such that the contracts of other states can refer to it, right? And then also it potentially breaches the confidentiality of upstream parties because all their states were being kind of commingled with the reference state, with the state used as reference data. The other way we can do it is via flows. So we just call out to an API and make some business decision inside the flow framework, but we don't. If we do it this way, then we don't have any kind of what I call ledger assurance. So we don't create an immutable fact that is authoritative at the ledger level, right? We're just doing stuff inside a flow. So that via flows doesn't really give us the same amount of assurance as it does via using contract states or indeed attachments. So you can use attachments for reference data. I mean, I don't really think they've been used that much so far in most apps I've seen. People might attach PDFs and stuff, but I haven't really seen much use of them. It does eliminate data duplication, so you don't get these very long chains of provenance, but you still get contention over the use of the attachment. Then there's also no notion of currentness with attachments as well. So you can't have a notary say, this is the most recent version of the attachment. The other thing you can potentially do is use an oracle, but you have to centralize all your reference data around the oracle. So any questions so far? Okay, cool. So what is a reference state? A reference state is just a regular contract state. So it's just a regular state. There's nothing special about it. You create it in the same way that you create other state types. However, it becomes a reference state when it's used in the new references list in the transaction builder. So before Corda version 4, there was a list for inputs, a list for outputs, a list for commands, and a list for attachments. There was a timestamp field, and I think that was it. Whereas Now in Corda 4, there's a references list as well. So if you include a contract state in that references list, it's actually a state and ref. The type is state and ref. So if you include a state and ref in that list, then the contracts of other states can refer to it inside the transaction. But importantly, it is that the contract code for any state and refs in the references list is not executed. So you don't execute the contract code for any states in that references list. And most importantly, it is not consumed when that transaction is committed to the ledger. So any state and refs in the references list are not consumed. However, the notary does check to see whether the most current version of that state is in the references list. If it's not, then the notary will throw an exception to say there's been a double spend and you're trying to use a state that's already been spent. So that's really all there is to it with reference states. There are some subtle things that I'll talk about a bit later on, but for now, that's basically it. And it's perhaps easier to explain it with the diagram. So at the top left, we've got a notation that I use for creating a state. You've got the kind of fuzzy lines for no input state, and you've got the box with A1 for output state. Then we've got this other transaction below that creates another state as well. I've just called this reference state, but of course, as I said in the prior slide, it's really just a contract state. It's just a regular state. And then we've got another transaction that consumes one state, creates two states, and also uses a reference state as well. And then we have the lines going backwards to donate the chain of provenance. So obviously, the input A1 links to the output A1 in the prior transaction, and likewise with the reference state as well. So here, just to reiterate, the reference state is a regular output state. There's nothing special about it. It just so happens that it becomes a reference state when it's used in the references list in the new transaction. Next, just to reiterate again, that this reference state can be used as many times as necessary or as needed before it's consumed, right? Before it's updated or consumed. So this reference state here, when we create it in the first transaction, there's just one version of it now. So we could have many, many, many transactions on the right-hand side, all referencing this output state, and it wouldn't be consumed at all, right? So that's really important to note. However, the maintainer or the updater of that output state, which is used as a reference state, can update it. And when they do update it, then they'll have to distribute the update to everybody such that they have the most recent version of it. Does that make sense so far? Okay, so as I said, the contracts of other states can reference the properties of the reference state. Because it's inside the transaction, you can see it. So that's all good. And the reference state contract is not executed. Lastly, the notary checks that it's current but doesn't consume it. So that's just a reiteration of what the rules are around reference states. All good so far? Okay. Ooh. Okay, so what do reference states actually enable? So what's the business outcome of this feature in Corda? That seems, I guess, a little esoteric if you look at it initially. Well, it enables you to reuse the same state in many transactions as reference data, right? So you eliminate this, hang on a minute, you eliminate the contention issue, you eliminate the long chains of provenance issue, and you eliminate to some extent the confidentiality breach as well. So this reference states feature solves all of those problems in one fell swoop, which is quite nice. But also at the same time, you still allow the reference data maintainer or the reference state maintainer to update that state whenever they need to. So what's an example of how you might use this? Well, in the token SDK that we've been building, there's this notion of a token. And usually, if you look at tokens to date, it's typically just some static information that is inlined into a contract state. So it's something like a currency like GBP or US dollar, Bitcoin, whatever, but it doesn't change, it's static. But what if you have some token reference data that needs to change over time? And the example I usually use is, say, an equity instrument. So an equity instrument has a life cycle associated with it. So you would you would create an equity instrument, maybe some, I don't know, Class A shares, and then there would be corporate actions associated with those Class A shares, like dividend payments, stock share splits, voting, all this kind of stuff. So to model that stuff on the ledger, you wouldn't really want to commingle the notion of ownership of some units of those Class A shares with whether a corporate action is happening, right? So what you want to do is separate the concerns of what is the life cycle of the token and what is and who owns some amount of this particular token. So indeed, we can do that. We can split these things up. And reference states is a really nice feature to enable this. So in a transaction involving, let's say, me selling 100 units of some Class A shares, I can have a state object, like a fungible, ownable state object that represents some interest in ownership of these Class A shares, let's say 100. And then I can have a reference state that details the current life cycle of those Class A shares as well. So they don't need to be in the same state object. And then if the issuer of those Class A shares wants to update the reference data to say, hey, we're going to announce a dividend, then they can do that independently of who currently owns those Class A shares as well. So what would happen is, on the second bullet point on the slide here, if a data distribution group exists, then they can just punt out the update to everybody on the network, and their vaults will get updated with the most up-to-date version of that reference data for those shares. Currently, distribution must be performed manually because we don't have a implementation of data distribution groups yet, but you can do it quite easily with just a simple distribution list that you can create in your Corda app. And we got some examples of how to do that in the token SDK. But I think that's a useful illustration of what reference states enable. They allow you to separate concerns quite nicely so that you're not commingling all your data in one state, which is not necessarily advantageous. It's bad for privacy reasons and such like. Okay, any other questions? Any questions? No? Okay. No? Okay, cool. So there's a slight change in the vault behavior since the introduction of reference states. So before, the vault would only store an input or output if it was relevant to that particular node. And what that means is that if that input or output had a public key in the participants list for that state that was known by the node. So this was a public key for a key pair that the node has previously generated. If so, then any input or output that had a public key match in the participants list would be stored in the vault. And that's how it works today as well. Though actually, truth be told, the ownable state is slightly different, and we've been having a bit of a discussion about this recently. With the ownable state, it's actually only the owner that defines whether the state is relevant or not, and the participants is actually ignored. So that's a little bit of a gotcha. But the new behavior with reference states is such that if there is at least one input or output in the transaction that is considered relevant to the node, then the node recording that input or output will also record all of the reference states in that transaction as well. And the intuition behind this is such that if you need to use a reference state to discern whether a transaction is valid, then you should probably have that reference state in your vault as well, so you can recall it at some point and see what was in it. But before, well, I don't know, let's imagine that this behavior wasn't there, and someone could include a reference state in a transaction, and it would be required to assess validity of that transaction. If it wasn't then stored in the vault, then it would be pretty confusing. So you would not be able to see actually what was contained within that state. Now, this presents a little bit of an issue because before in Corda, well, certainly in Corda 1 and most of the time in Corda 2 and 3, your vault only really contained states that were relevant. So states that had a public key match in the participants list with one public key of a key pair that you have generated prior, right? However, now this is definitely not the case with this new reference states behavior. You'll end up storing states that are not relevant for you, that you cannot spend, right? Because the maintainer of that reference state is unlikely to be you. You're using this reference state because you need it to perhaps verify one of your transactions, but you're most likely not the maintainer of this reference state. So we introduced this concept called relevancy status, which is a new I guess, Vault query flag. You can see it in the common query criteria in the Vault service KT file. And what it does is every state that is stored in the Vault gets a relevancy check. So if the public key matches one which you've got, then you get a 0, I think. And if it doesn't, then you get a 1. I don't know why it's that way. It's a bit counterintuitive, but that's the way it is. And if you perform a Vault query with relevancy status only relevant, then the query will only return those states which are relevant. So let's say someone uses a cache state as a reference state in a transaction. You will then store that in your Vault, even though it's not relevant for you. And if you then query the Vault with relevancy status all, then you will get that cache state back when you do the Vault query, which is obviously not ideal if you want to, say, total all the cache states which you own. So what you do is you set the relevancy status to only relevant, and then you'll only get your relevant states. I realize that's a bit confusing, counterintuitive, and annoying, but that's just the way that Corda is. I mean, I think we should remove the concept of relevancy and just store everything, but that's a discussion for another day. Okay, so I think actually this slide is, my flippant comment aside, is actually really important, because this, if you're supporting Corda developers that are having problems with the Vault returning states that they might not necessarily expect to be there, then this is likely to be the key reason why. So make sure everyone is aware of this relevancy status flag in the Vault query criteria, because it's going to be important going forward. So I think if there's kind of a main takeaway from this presentation, it's probably this slide, really. Any questions? Okay.
Maybe are you coming to the V3 to V4 migration implications of that? To tell people to be ready for the startup time.
To talk about the process of migrating. Yeah. So yeah, Richard just mentioned that I should talk about migration from Corda 3 to Corda 4. So let's say you have a bunch of states in the Vault that were created on a Corda 3 node. There was no concept of relevancy status in Corda 3. However, in Corda 4, obviously, the new column has been added to the database. So how do we update the Vault from version 3 to version 4? It's a little tricky, because we can't just populate the relevancy status column with all zeros or all ones, because we'll end up screwing up we'll end up screwing up the Vault, and your Vault will return all the wrong states. Your Vault queries will return all the wrong states. So what we need to do is actually, when we upgrade our node from version 3 to version 4, the first time it happens, we need to run a migration process. And what it does is it starts up the node in I think it's a migration mode. But this happens autonomously. And what you'll see is that your node will say, there's X many states to migrate. This may take a little bit of time. So if you have 100 states, then what you need to do for each one of those 100 states is figure out whether that state is relevant or not. So you need to deserialize that state object, figure out who the participants are, so figure out what those public keys are, and then see if we can get a match with one of the public keys that's already stored in the key management service. If there is a match, it gets a relevancy status 0. No, hang on a minute. This is the confusing element of it. Well, basically, if it gets a match, then it's relevant. If it doesn't get a match, then it's not relevant. So It will, potentially when you do upgrade your nodes, you might see it doing that for a while. But don't panic, that's expected. And then once it's finished that, then the node should just start up normally, and all of the states that were v3 should now have the relevancy status for v4. From that point onwards, you can use the relevancy flag when you query the vault. I hope that makes sense. And of course, all of this is documented as well. So you can see in the Corda open source and enterprise docs how this works. Okay. So how do you actually use reference states? It's probably one of the most important questions in this presentation. Well, it's actually pretty easy. All you need to do is get a state. Here, I'm using type inference, but this is a state and ref here from the vault. So we're getting a single state from the vault, and it's a type state and ref foo. And then there's this new extension method on state and ref that allows us to get a reference version. So what it does is it just wraps your state and ref in a referenced state and ref. It's just really syntactic sugar to allow the transaction builder to easily handle reference states. And then what you do is you add your reference state and ref to the transaction builder using add reference state. And that is literally it. That is the sum total of the API for reference states in Corda. So obviously you'll notice that the API doesn't have a large surface area. There's literally only 2 methods that have been added. However, the implication of the data model change is pretty significant, right? So you need to remember all this stuff about how reference states behave and potentially change, and also potentially change the behavior of the vault as well in this slide. So despite it being a very small API change, it does have big implications to the data model. Okay. Yeah, so easy. There we go. Next one. So how do we build this? And I guess it's worth just going through super quick how it worked. The important thing to note here is that reference states requires a minimum platform version upgrade. So you can only use it when all nodes are Corda minimum platform version 4 on your network, right? So that is really important. So you might have some customers say, well, why can't I use reference states? I'm using Corda version 4. Well, the reason why is because the minimum platform version is probably 3 or less. So that's the reason why. So it needs that minimum platform version 4. The other things that we did were add this references property to the transaction and component groups in the wire transaction for this. We changed the notary services a little bit. So the notaries do process reference states, of course. So they check to see whether the state refs for those reference states are in the spent list, but they don't actually spend those reference states. They don't actually, yeah, they check to see whether they're in the spend list. Obviously, they have to check that they're current, but it doesn't add them to the, no, does that make sense? Am I just confusing myself here? Yeah, so the notary checks to see that they haven't been spent, but it doesn't spend them when they're used in the transaction. So I was tying myself up in knots there. What else have we got here? Oh yeah, we had to change the transaction resolution flows as well. So before they just resolved input state refs, but now they resolve reference state refs. And then we added a new flow as well called with reference states flow. So this is actually quite interesting and could be used in a variety of use cases. So imagine you have some reference data, a reference state that you need to use in a transaction, but the maintainer of that reference state has just updated it, and the new updated version of it hasn't propagated to you yet. So essentially what you have here is a race condition between the point where you want to use this reference state in a transaction and the maintainer of the reference state updating it. Of course, at the moment the reference state is updated by the maintainer, when you try and commit your transaction to the ledger, i.e. get it notarized, then the notary will turn around and say, hey, you've got a double spend, so you can't actually commit this transaction. So what the with reference states flow does is it tries to commit the transaction in a in a continuous loop, and it interprets the notary exception to see if it's a reference states exception. If it is, then we know that a race has occurred and the maintainer has updated that reference state. So what we do is we pause the flow and we wait until the reference state is consumed, i.e. you have received the new update for that reference state and the new version of it has been stored in the vault, at which point we know that if we try and we try and commit that transaction, then we know that it can be committed to the ledger. So that's quite a nice little workflow there to use with reference states. If in your customers' flows they might be susceptible to update races. And that pattern can be used in other areas too.
Just on that one, just make sure I understood that one. That means a transaction I've signed inside this flow, the flow could state and then automatically re-sign it, or it does something else?
So the way it actually works is via linear states. So because the linear ID is always the same, actually, hang on, you know what, I can't remember because I wrote it 6 months ago. I'd have to actually look. So maybe Richard, I'll come back to that actually. I'd need to check the
cool, okay, thanks. Cheers.
I can't remember. I'm pretty sure it does rebuild the transaction. It would have to. Yeah. I think what happens is that it runs the flow again that creates the transaction from scratch and does it that way. But I'll have to check the code to be sure. So this was a slide actually I used a while ago. It was targeted at the Corda developers, and basically just keep in mind that if you change anything to do with, say, the notary, then you've got to keep reference states in mind, because otherwise you might break it if you weren't aware of the feature existing in the first place. So just a quick slide on when to use reference states versus attachments versus oracles. I'd say use attachments if you have historical data that doesn't change very often, like FX rates, for historical FX rates, i.e. not current ones. Stuff that can't go in states or stuff that doesn't go in states particularly well, like Excel spreadsheets or PDFs, or bytecode, obviously, for attachment, for contract attachments, or things like images, stuff like that you can't really include inside your state schemas. You would typically use oracles for frequently changing data, like current FX rates. So if you need an FX rate on a, per second basis or whatever, then you probably want to use an oracle and not an attachment, obviously. If you need an objective third party, for example, to check to see whether you can exercise an option to see what the strike versus the underlying price is, then you would need to use an oracle service. Also, as well, if the data is proprietary, then you'd probably want to use an oracle service as well. However, where do reference states come in? When would you use them? Well, I mentioned already reference data for tokens, which I've included here in the first bullet. KYC data, and something here I've got a point, you can maybe use it for collateral management. So let's say you wanted to prove to a party that you had, X amount of, greater than X amount of cash at any one point in time, and you wanted this to be authoritative at the ledger level, well, you can include those cash states in a transaction as reference states. Then you can have another contract to check to see whether the amount is greater or equal to some pre-specified amount. And then you can commit a state to the ledger depending on what that amount was. So the reference states allow you to do more things at the contract level than you could do previously. Because the only way to include cash states in a contract before, in a transaction before, would be to actually spend them. So now you can just include them as reference data. So it's a good point, actually. You can use any state as a reference state. So even fungible, ownable things you can use as reference states. But I think typically you'll probably just see linear states as reference states most of the time.
Hey, Roger, quick question about that slide. Sorry, it's Daniel here. I was interested in the oracle versus reference state and the notion of it being, distributed versus centralized. And I think that the slide answers that question. I'm just interested in, when you say reference states can be provided by issuers, in what way is that different than objective third parties? Are you implying that there could be some kind of consensus around issuance, and then a reference state can then be governed by the issuer? Or I'm just kind of interested in the subtlety there.
It's a good question, actually. So you're right in saying that, let's say, instead of using a reference state, the issuer could just use an oracle. Let's say its reference data about a financial instrument that is originated by the issuer. Then, yeah, it doesn't matter whether you use an oracle or a reference state. The difference is, though, that an oracle is kind of more centralized because it has to be highly available, because it needs to sign every transaction involving that bit of reference data. Whereas if you have a reference state, then the issuer doesn't need to be highly available for use of the reference data. So it's actually preferable from a decentralization perspective to use reference states over oracles, if you see what I mean.
Yeah, that makes sense. So it's not so much about ownership of the data, it's more about kind of the practicality of operationalization of that data. So being that signing party on every single transaction versus issuing it once, owning it, and then pushing it out to everybody else. Is that accurate?
Yeah, exactly. So it only needs to be involved with the reference state when it's being updated. But as long as it's on the ledger, then anyone can use it, right? So it's really useful for data that changes reasonably often, but not too often. If the data changes very frequently, then you probably have to use an oracle. But if it changes, say, once a week or once every couple of days, then probably a reference state is better.
Okay, that makes perfect sense. And just one note on that update. So if I create a reference state and I want to update it, I'm potentially only the only signing party on that state. I update it myself and push it through a flow to everywhere that it exists elsewhere in the ledger. Is there a special flow to do that that's other than the kind of collect signature flow?
It's a good question. Again, no, there isn't at the moment. What we need is data distribution groups. So we need a way to proliferate these updates around the ledger. So in the white paper, Mike wrote about clubs or data distribution groups that would facilitate this. So I've got a prototype of it in the Corda repo on, I think it's called like ROG Data Distribution Groups branch or something like that. You can have a look at it for how it works. But for now, you can facilitate something that's kind of okay enough for now by just creating a distribution list. So the issuer just creates a local database table in their database and just lists the I don't know, probably the linear ID of the reference state and the party that wants to receive an update. And then every time you update that the reference state with that linear ID, then you just send receive transaction flow to all parties that are on the distribution list for it. So you could do something like that. I mean, it would take, I don't know, 10, 15 minutes to write. If you look in the token SDK, I've got an example of how to do that actually, because I have to use that in the absence of data distribution groups. But yeah, in short, you have to roll your own. But you can use examples that exist elsewhere.
Okay, perfect. Thank you.
No worries. Thank you. Okay, so outstanding issues. So there's a bit of a problem with notaries at the moment and reference states, because if you try and use more than one reference state in a transaction and those reference states have got different notaries, then you probably cannot commit that transaction to the ledger, because probably it's most likely that you don't have the right to change the notary on that state. So you just won't be able to commit it to the ledger, which is a bit of a problem. There are a couple of ways around it. Maybe one is just to issue the same reference data onto every notary that's available on the network. But then that would confuse your vault, because you can't have multiple states with the same linear ID. So that would create another problem. So you would have to have the same reference data with different linear IDs on different notaries. I don't know, maybe that's acceptable for for the use cases that would require reference states. Who knows? We need to do more exploring into this. The other thing is if we essentially disallow notary change transactions and require each issuer has their own notary. I think we might end up having to go down that route anyway for other reasons, but that's one other possible solution. The other question is, should we allow fungible states to be referenced? Some people say yes, some people say no. I don't really care for the time being, but I think that's something we should maybe think about a bit further in the future. How does the Vault handle reference data properly? So I spoke about the relevancy stuff. We need to put more thought into this because the semantics around whether the Vault stores a state or not is actually incredibly confusing, and it's the source of quite a few bugs. So we need to rethink, I believe, how we do this. I mean, if you encounter customers that are having problems with this type of stuff, then it's probably due to not fully understanding the behavior of the Vault. A lot of the behavior is quite opaque. It's difficult to actually understand what's going on without literally stepping through each line of code in the debugger. So, I mean, if you do get those, if your customer with problems like that, then just, I don't know, let me know and I can perhaps help them out. The last question is, do we allow encumbered states to be referenced? So imagine you've got, let's say, some cash which is encumbered by the regulator because it's, I don't know, impounded for some reason. Can you actually include that as a reference state? The answer is probably not. Or maybe you can be included as a reference state, but it needs to be known that that state has been encumbered by another state, and that other state also needs to be included as a reference state. So I don't know, that's a bit confusing, and we probably need to figure that out, because at the moment there's no support for encumbrances with reference states. But as I understand, not many people are using encumbrances, so I don't think that's an issue for the time being. It's something we can revisit in quarter 5. So I think that's it on reference states. So on JPA, I'm just going to keep this pretty short because this is a really simple feature and it doesn't require that much explanation. So before, developers had access to use this JDBC connection method in the Service Hub. And what it did was it gave you essentially free access to the database. You could literally do whatever you wanted, which is nice if you need all that power, but probably most of the time you probably don't. And it's also cumbersome and annoying because if you want to create, if you want to store some off-ledger data, you have to use DDL to create your own table, and then you have to create your own queries to update it and pull data from it and things. It's easy to make mistakes. But now developers can use JPA inside their flows. It's very, very simple. So it just uses Java Persistence API. And here you can just see a very simple entity that has an ID and some data, which are both strings, with the ID being the primary key. We call that table foos, and we call the entity persistent foo. If we want to create an instance of an entity, it's super simple. We just create a persistent foo with a new ID and some data. Happy days, very easy. Then if we want to persist it, then we literally just call with entity manager, which takes a Lambda function as a parameter that gives us access to the entity manager. And on this entity manager, we can do things like persist, flush, query, all the standard stuff that you'd expect to be able to do with JPA. The important thing to note is that this entity manager is restricted, so you can't do things like close the database transaction and do dumb things that would break the node or break the flows. So it is restricted to some extent, but you can do all the stuff that you would expect to be able to do, like persist entities and query entities. If you want to query the entity, then you can use some code like this. To be honest, the Java Persistence API is quite verbose and not that not that good really, but it's much nicer than writing SQL. There's another way. You can use JPA queries. It's like some domain-specific language for doing queries using JPA. It's actually a bit nicer than this, but I just thought I'd demo this way of doing it. So you can create a new query. You can say, I want to query using this particular entity and from this table, and then just perform a select query, and it will return the things as a list. This is basically what the Vault service does. It kind of gives you the same power that the Vault gets, except obviously all this stuff is hidden behind the Vault API, so you don't see it. There is one thing that you can do that I didn't mention, actually. So this persistent foo doesn't implement anything. It's just a class in its own right. But you can implement mapped schema, which is an interface in the Corda node API, I believe. And if you implement this interface, then that entity will be known by the Vault service. So you can do joins between this entity that you create and other entities that are defined by the Vault service. So that could be quite useful in the future. And indeed, the new accounts feature, it's not really accounts yet, it's more like account enablement. It uses the map schema interface, so you can link those tables to other tables in the Vault. So just one more thing just to reiterate. You will get an unsupported operation exception if you try to do things like close the database transaction inside the Lambda that you pass into with Entity Manager. Also, you can't do things like sleep the flow. You can't suspend. You can't do anything suspendable. If you try and do anything suspendable, it will break. So you need to make sure that you don't do suspendable things inside the Lambda block. So that's any send, any receive, any sleep. Trying to think what else might cause it to suspend. I think that's it off the top of my head. Calling a subflow that starts a new session, that would cause it to suspend. So you don't want to do any of that stuff inside that Lambda, because it will break your flow. And you can do more complex stuff like do one-to-many mappings with JPA entities, and you can do all of that stuff, but I just thought I'd demo something more simple today. I think that's it. Any questions on JPA? Yeah. Do you want the thingies through?
Thank you. Which types can you define as a column? And the context is I'm having terrible difficulty because I wanted to put a state ref in there as one of the columns, and I can't get it to work.
You put a what, sorry? A state ref?
State ref. I've got a state which has got a reference to another state within it, and I want to be able to look up into my persistent blah 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 by saying go and find the state which refers to this other state.
Right. So I think I saw your snippet of code.
Yeah,
I think
on it.
you can't do it without defining, I think, a hyphenate column converter or a JPA. Essentially, you need to be able to convert that type to something that can be persisted in a column in the database table. So we do that for party objects. I think what we do is if you put a column as type party, then what we do actually is extract out the X500 name, and then we persist the X500 name, which is just a string. And then when we do a query and then we deserialize the X500 name, you don't just get a string, it kind of rehydrates it into a party object. So essentially we need the same thing for static pointer, state ref, and all these other bits and bobs. Alternatively, what you can do is you can just store the state ref as a string and do it that way, but that's a bit of a hack. So probably the best thing to do is on your column, you can add a column converter, and it's essentially just a way to serialize and deserialize that state ref. So if you store it as a string with the, I don't know, I don't know, it's actually a bit more complicated than that because
I'm aware of derailing the conversation.
you could, yeah, I mean, let's just say you store it as a string with the first, or a pair, the first part being the hash, and then you do a comma, and then you have the output index. Then you can quite easily deserialize that into a state ref, right?
Yes.
Using just a simple column converter.
Okay, that's the approach that I've been taking, and it's not working for some reason. So
Oh,
I was just
okay.
wondering,
Well,
what's the so the kind of specific question for now is what are the different types that you can have as a column? Because you could, for example, you can't have a state ref as we just described, but you can have a string because it's on the screen.
I don't know. I don't know that much about JPA, but I suspect there's a lot of built-ins, so you can probably persist things that are in the standard Java libraries, like UIDs and dates and times and all that kind of stuff. I suspect there's support in Hibernates for all of that stuff. But when you go to more exotic types or types that we have defined in Corda, then you need to start defining your own column converters for those.
That makes sense. Thanks.
Yeah, no worries. Any other questions? I think that's it. Cool. All right, thanks, guys, for listening. And if you have any questions on this stuff, then just let me know on Slack, drop me a message, and I can help you out. So thanks for listening. Cheers.
Thank you. Bye-bye.